Okay, let's look at a couple more examples of hypothesis testing. Number one, a medical school claims that the mean MCAT score is no more than 499 points. A sample of 100 medical students has a mean score of 502 points. Assume the population standard deviation is 10.6 points. At the 0.01 level, test the school's claim. Okay. Now, clearly in this problem, we're talking about mean. State the claim. The school claims it is no more than 499 points, which means less than 499 points, or equal to, because no more than means this 499 is a limit. State the hypotheses. The claim contains equality, so it goes in the no. Less than or equal to 499. Alternative is greater than 499. Okay, what else do they say? Sample size is 100. The sample mean is 502. Assume the population standard deviation is 10.6. Alpha is 0.01. Now, because we have population standard deviation, we'll use the Z distribution. The alternative is greater than, so this is a right-tailed test. Let's do the rejection region first. Reject, fail to reject. Now, we need to know what the Z critical value, which separates reject from fail to reject. Well, the alpha value is 0.01, which means the area to the left is 0.99. That is the area. If I have the area and I need the Z, I can use the inverse norm function. Inverse norm of 0.99, 2.33. So that'll separate reject from fail to reject. Compute the test statistic. Sample mean is 502. Population mean is assumed from the claim is 499. Which is 3. 1.06. 2.83. Now, 2.83 is greater than 2.33. Therefore, we reject the null hypothesis. Conclusion. Go to the diagram. Does the original claim contain the condition of equality? Yes, it does. Do you reject the null hypothesis? Yes, we do. There is sufficient evidence to warrant rejection of the claim. We should say the medical school's claim that the mean, get the parameter in there, MCAT score is no more than 499. Now, if you were to use the p-value method on this problem, still use z-distribution, still right tail. The test statistic we got was 2.83. Now, the p-value is the area in the tail. To find the p-value, we can use normal CDF. Normal CDF. The left-hand boundary is 2.83, comma. To the right, it'll go forever. I'll say 999, comma 0, comma 1. The p-value, 0.0023. The alpha value is 0.01. The p-value is smaller than the alpha value. Therefore, you would still reject. Okay, let's see what's next. Question 2. A college brochure claims that the average class size is less than 32 students. A sample of 18 classes at the school have a mean class size of 30.2 students and a standard deviation of 4 students. Test the school's claim at the 0.05 level. Okay. State the claim. Again, we're talking about mean in this problem. This college brochure claims the class size is less than 32 students, which means the null and alternative claim does not contain equality. It goes in the alternative. And the null would be greater than or equal to 32. What else do they say? We take a sample of 18 classes. The sample mean is 30.2. Now, the standard deviation here for students comes from the sample, which means we're using S. Which means we need to use the t distribution on this problem. Alternative is less than. This is a left-tailed test. We need to know the t critical that separates reject from fail to reject. If we go to our t table, the alpha value in one tail is 0.05. N is 18, which means degrees of freedom are 17. So one tail, 0.05, we go to the second column. Degrees of freedom are 17. If we scroll down, 1.740. Which separates reject from fail to reject. Let's find the test statistic. Similar to the previous problem, but we're using the sample standard deviation. Sample mean is 30.2. Population mean is assumed from the claim, which is 32. Sample standard deviation is 4, N is 18. negative 1.91. And I've clearly made a mistake here. Look at this. The table told me 1.74. The table doesn't know that this is on the left. This needs to be what? You're right, negative 1.74 because this is on the left. Now our test statistic is negative 1.91, which is smaller than this, which means it lands in the rejection region. Therefore, we reject the null hypothesis. Conclusion. Does the original claim contain the condition of equality? No, it does not. Go down. Do you reject the null hypothesis? Yes, we do. The sample data support the claim. Whose claim? We're talking about the school's claim. That the mean class size is less than 32 students. Now, if you wanted to use p-value, you absolutely could. Still doing t-distribution, still a left-tailed test. The test statistic we get is negative 1.91. The p-value is the area in the tail. We can get that area using the t-CDF function. t-CDF. The left-hand boundary is forever, so let me say negative 999, comma, negative 1.91, comma, now we need degrees of freedom, which were 17. The p-value, 0.036. The alpha value, 0.05. This is less than the alpha value, therefore you would still reject the null hypothesis. All right. What's next? Question 3. An educational research firm claims that 57% of college students work. In a sample of 300 college students, 175 work. At the 0.1 level, test the firm's claim. Okay. Now, it's clear that we're talking about proportion in this problem. The educational research firm claims that 57% of college students work. P equals 0.57. The null hypothesis is equal. The alternative is not equal. Okay. The sample is 300. Of those, the number of successes X is 175. The alpha value is 0.05. Now, proportion always uses the z distribution. Because the alternative is not equal to, this is a two-tailed test. Reject, fail to reject, reject. Okay, we're going to have two z critical values which separate reject from fail to reject. Now we have to be careful here because the alpha value is the area in the tails, 0.05. We have to split that equally two ways. So we divide that by 2 to get 0.025. So if I wanted to get this value right here, I can use the inverse norm function. .025, 0, 1. Negative 1.96. Which means the other critical value will be positive 1.96. Let's find the test statistic. Wrong formula. This is proportion. P hat minus P over square root of PQ over N. Now, right off the bat, we don't have P hat, which is sample proportion. It doesn't mean we can't find it. P hat is simply X over N, which is 175 over 300, which is 0.583. And now we have everything we need. 0.583 minus population proportion is assumed from the claim. 0.57, P is 0.57, Q is 1 minus P, which is 0.43, in the sample size is 300. Zero 0.45. Now, that number is between the critical values. It'll be over here somewhere. We fail to reject the null hypothesis. Therefore, fail to reject H0. For the conclusion, does the original claim contain the condition of equality? Yes, it does. Do you reject the null hypothesis? No, fail to reject. There's not sufficient evidence to warrant rejection of the claim. I should say the firm's claim that 57% of college students work. Now, if you wanted to do this problem using p-values, you could. Still using z. Still two-tailed. The test statistic was 0.455. And the area in the tails would be the p-value. So let me find the area in this tail using normal CDF. To the left is negative 999 up until negative 0.455, comma 0, comma 1. 0.325. This is not the p-value. P-value is the area in both tails, so we'll just times this by 2. .65. The alpha value was 0.05. This is definitely greater. We would still fail to reject. Okay, what's left? Question 4. A school principal claims that the standard deviation on math tests is less than 35 points. A random sample of 28 math tests has a standard deviation of 34 points. At the 0.01 level, is there enough evidence to support the principal's claim? Sure. Okay, we are definitely talking about standard deviation here. The principal claims the standard deviation is less than 35. The claim does not contain equality, so we move it to the alternative, which means the null will be greater than or equal to 35. We have a sample of 28 math tests, a sample standard deviation S of 34. The 0.01 level, is there enough evidence? Sure. Now, since we're talking about standard deviation, we're definitely going to use the chi-square distribution. Something like this. Because the alternative is less than, we need to know the chi-squared critical value, which separates reject from fail to reject. Okay, remember the chi-squared distribution needs the area to the right. 0.01 is the area to the left. So if I do 1 minus 0.99 is the area to the right. N is 28, which means degrees of freedom are 27. All right, if we go to the tables, area to the right is 0.99. Degrees of freedom are 27. If we go down to 27, 12.879. Let's find the test statistic. It's 28 minus 1. Sample standard deviation is 34. We assume the population standard deviation is 35. The chi-squared test statistic is 25.5, which is definitely greater than the critical value. Therefore, we fail to reject. All right, conclusion. Does the original claim contain the condition of equality? No, it does not. Go down. Do you reject H0? Fail to reject. No. There is not sufficient sample evidence to support the claim. We should say whose claim? The principal's claim. That the standard deviation make sure you get the parameter in there, of math test scores is less than 35 points. You have to write all of that out. Yes, you do. And we're finished with the problem.